Okay, these are matrices. These are a collection of numbers in rows and columns. We'll do all sorts of fancy things with them. But the first thing that we need to do is we need to be able to identify how many rows, how many columns there are, because each of these has names, like a 2 by 2 matrix or a 3 by 4 matrix or something like that. So any of these matrices have m number of rows times n number of columns. That's what it's saying when it's asking you to state the dimensions of a matrix. So if we look at this first matrix here, let's count the rows, and these are the rows, like across. So that has 3 rows, so the first dimension is 3, and it's a 3 by, well, let's see, how many columns? 1, 2, 3, 4 columns. So that first matrix is a 3 by 4 matrix. The second matrix over here, well, let's see, we have 1 row, so it's a 1 by 1, 2, 3, 4 column. That's a 1 by 4. This other one over here, number 3, has 1, 2, 3 rows times 1 column. That's a 3 by 1. And this last one here has 1, 2, 3, 4 rows by 1, 2, 3 columns. Now, being able to do dimensions is important, especially when you're doing any sort of operations with these things. Something else that you may be asked is, like, if we call this matrix matrix A, and I were to ask you where, or rather what element is in row 1, column 4. Well, you would look to row 1, which is right here, and you'd look to column 4, which is right here. So 9 is in row 1, column 4. I don't know why I wrote a 4 there. It should be a 9. If we look for, I don't know, matrix A, what element is in row 3, column 2? Well, let's see. Row 3 is right here. Column 2 is right here. So there you go. A 2. There are dimensions. All you have to do is count the number of rows, count the number of columns, and state it as such.